Hi, welcome to the tutorial on verifying the assumptions of linear regression. By the end of this tutorial, you will be able to verify the assumptions of linear regression. So far, we have performed the first 8 steps of implementing linear regression, and now is the time to move forward to our 9th step, that is, verifying the assumptions of linear regression. As we know that most of these assumptions required making of the residual plot. So let's prepare for that. For this, we use the predictions we generated using the linear regression model and the X test data and subtract the actual values of Y test from it. This gives us the difference between the predicted and the actual values, also known as the residuals. In the third line, we will be arranging the predictions and the residuals in a data frame. Once we do that, we will sort the residual table values using the predictions. By doing this, we can obtain the residual values arranged with respect to the predictions in ascending order. You might ask, why are we arranging the residual values? If we recall, we did not use any independent variable while plotting the residual plot of the mean regression model. Why? Because we did not use any independent variable while building the mean regression model. But now, we are looking at multiple independent variables in our linear regression model. But the next question is, how do we visualize the residual plot where we have multiple independent variables? In this case, we will be using the predicted values or the y-hat values because they represent the effect or outcome of all the independent variables combined. In the next two lines, we declare two lists. Z contains the numbers from 0 to the maximum value of the predictions. K contains the zeros. Number of zeros are same as length of Z. So let's run this cell. Now that we have the lists ready, let's plot the residuals. In the first line, we define the size and the resolution of the plot. In the second line, we define a scatter plot with predictions from the residual table as the order of fitted points on the x-axis and residuals on the y-axis, which are ordered with respect to the prediction in ascending order. Note that parameter S represents the size of the marker in scatterplot. Feel free to play around with that parameter. In the third line, I am defining a plot which will represent the regression line constant at 0. For this, I am passing list Z on the x-axis as the fitted points and the list K which represents the zeros on the y-axis. So let's run this cell and see the resultant residual plot. Firstly, we can see that most of the residuals are densely populated between the limits 200,000 and minus 200,000. So, there is a good probability that the residuals are normally distributed. Second, if we compare the residual plot to the ones we saw in the assumptions of the linear regression, we can see that our residual plot resembles neither the cone shape nor the pipe shape. So as a result, our plot lies somewhere in the middle, and therefore we have some scope of improvements which we can make in our data. We will be looking at how to do that in the subsequent tutorials. Third, we can also see that we have some outliers with positive magnitude in our residual plots. Perhaps our data in the current form is not able to explain the presence of outliers. We will look into this further in the subsequent tutorial. Now, let's check the distribution of the error terms. For this, we first plot the histogram by passing the residuals as parameter. So let's run this cell and see the results. We can clearly see that the bulk of the residuals follow the normal distribution, and hence the residuals follow the normal distribution. But we can also see some outliers on the far right of the plot. Now that most of the things look fine on checking of the assumptions, we will now look over the magnitude of the coefficients using a bar graph. We will do that in the next video. See you then.